It says, so part A says determine the radioactive sample's original mass. So we have to come up with its original mass. That means the starting mass. So the original mass will equal the sum of the remaining radioactive plus the what has decayed into the stable daughter. So what remains radioactive plus now what is the stable matter. So the original mass in this problem is equal to the 125 grams that is still radioactive plus the 875 that has decayed into stable matter. So that gives us a starting mass of 1,000 grams. Okay? So let's take a look. We have to now determine the number of half-life cycles that have occurred. Okay? So when we fill out this chart for the cycles, we start with cycle 0, and we want the original mass, which is 1,000. We just number the cycles until we get to what is the ending mass. Well, the mass that remains, this is still what's radioactive, so this would be the end mass that we want to get to. So 1,000 is cut in half to 500. 500 becomes 250, and here the 250 becomes 125. So to go from 1,000 grams of radioactive material to 125 grams still radioactive, this required 3 cycles to occur. Now it says, for this last part, it says determine the amount of time that has passed if the radioactive sample is p32. So p32, that tells us the identity of the material. Find it on table N. So on table N, the half-life rate is 14.28 days, I think. So here we go. So we know it went through 3 cycles. So it went through 3 cycles, and it is 14.28 days per cycle. Cycles cancel out, and so we know that around 42.84 days have passed. That's the total time that has passed.